So we'll go ahead and start right here. Right here. Okay. So as soon as you guys download Space Teams Pro 0.20.5 or any future releases, you'll unzip it inside your user slash whatever folder, and this is to prevent a path length issue. It's not fixed as of 0.20.5, but maybe fixed in future releases. After that, you'll go into your file structure here, you'll see a compute server, shared data, spacecraft. So you just want to go into spacecraft for your first time setup, and you're going to run this batch script. I'm not going to run it now because it's already been done on this computer, but double click on that first time setup.bat, and that'll really get all of spacecraft working on your computer. Okay, so moving on, we're going to go ahead and get into how to write your first example Python systems, but really we're going to show this Python, the structure here with packages. This is where the template's going to live inside of compute server packages, template Python. And so inside of here, we've created a few example scripts for you guys, example python.bat, template Python, which you can use to create your own system starting out, set location and rotation, and simglobals.py. And then inside of here, we'll have an example Python sim.json, which kind of is a simulation config for the sim that we're going to be going through. Okay, so opening that up inside of our Visual Studio Code. One of the first things that you want to notice is that we have some nice highlighting with space teams, and that's because we've set the interpreter, the Python interpreter inside Visual Studio Code, to be pointed towards the Python within space teams. That's a little bit deeper within space teams. Do you want to?
And the easiest way to do that is to just go here and in your Explorer, you open up a folder. If you don't have anything open, that's what you'll see. You'll see the option to open a folder. Open the compute server folder. And then if nothing happens, if it doesn't populate an interpreter down here, then all you're going to do is click that and then enter interpreter path, go to find, and then go back up to compute server, go to externals, VC package, packages, and click through all of these until you reach this one that has python.exe. Click that, select interpreter, and there you go. Sometimes it might complain that it's not a valid interpreter. It is. Don't worry about it.
Right. Good. Okay. So after you have that set up here, now you'll have the ability to look into the Space Teams module. So you'll have like Python, you'll have the ability to look into the Python functions that are packaged within it, which is nice. So we'll go ahead and start out a little bit in this first area with the just kind of an example Python system. Going through this right here, we put a bunch of notes inside of here, but really this first Python script is going to just be telling you how to print hello world within space teams, getting entity references, just basic on-screen messages and alerts. So that's all included inside of here. So the first part of this code here from line 6 to 14, don't change any of this. This is so then we can connect into space teams from Python. Those are just the system, what we call a system boilerplate part of the code.
Yep, and that's basically every Python system is treated as a client in the sim. So every new Python system that you add is going to have to connect itself to the sim, and that's what this part of the code does.
Correct. After that, you're going to go ahead and do your imports, such as import NumPy, import copy. Those are things that are within the Python environment that's inside of Space Team. So we'll probably have another tutorial on how to add imports if you have something that's outside of some simple ones such as NumPy and copy, but we'll talk about that in another video ahead. Next thing, we have a couple of on-screen message functions. So this is just a couple of user functions that give you the ability to, within a sim, say I want to see like an on-screen message pop up with some sort of string and a severity. We'll talk a little bit more about that severity later, but this is just the two functions that you get. You get an on-screen log message, and you also get an on-screen alert that you can get from within Space Teams. So we'll go through the section 1 here. So section 1 goes through really the logging part. This talks about how we go through Hello World, really. So using Space Teams, you're going to go ahead and above, you've already imported SC. So sc.loggerinfo is going to be the function you're looking for if you want to log Hello World inside of a log file within Space Teams. There are also a couple other related print options here that we've commented out. Alex decided to comment out some of these other pieces here, which we won't go through, but really there's sclogger.warn, and then it'll really give you a warning. So it's very useful for debugging, as well as sclogger error and sclogger fatal. And the fatal error also will call, I believe it'll call a sim end, a
Yep,
sim
it
stopping.
calls sim stop because that means you've hit something that it cannot continue past.
Or it should
So
not.
you can call that yourself. Be very careful with it though.
Yep, it's like a cut everything, this is broken nuke.
Yep.
So there really is the first section for Hello World. That's good. Okay, moving on to section 2. This is really on-screen messages and alerts part. So using those logger functions that I've talked about above, you can put alerts with a severity tied to your alert. So say you have like a message here. Here's my message, this is my alert, and I say the severity is 0. Severity 0 corresponds to if it is just a message on your screen, nothing too crazy. Severity 1 runs that logger.warn, and severity 2 is going to be that that error, logger error function that you're looking at. So whenever you put these messages up and say severity, also put note that this is very useful for debugging, but also is like here is an error, or here's not an error. This is just some info that you want to display on your screen. Use that as you want.
There's no option for a fatal on-screen message for pretty obvious reasons here.
Yeah, because you don't want to break your sim just from pulling in a comment, right? All right.
Yeah, so that's about it for on-screen messages and logging. So let's see how the sim behaves at runtime.
Yep. So this is the third section here. So instead of a C++ system, which you guys haven't, which you guys might or might not have gone through with the video series, there's like a predefined update step or function that does runtime looping for you at some specified hertz. Inside of Python systems, we don't have that looping functionality built in within Python. And so you must write something sort of like the following, which is essentially you have an exit flag, which will say false. You'll say false, and then while not that flag. So while it's true, it'll continually loop forever.
So let's go to the end. What happens if you skip past that loop?
Yeah, so as you go past, if say you want to end the loop exits, you trigger that exit flag, you'll trigger what's called a leave sim. So really that sends to the simulation environment, hey, stop the simulation, kill it, it's done.
Yeah, so it's unintuitive a little bit that leave sim would like cause a sim to end, but it does because this Python system is a client basically. And if one of the clients that's supposed to be in the sim leaves, that means you stop the sim.
Yep.
So, yeah. So keep that while loop going as long as you want the sim to run, basically.
So we'll dive a little bit into each of the things within this while loop. So this is kind of like the core part of your system. First thing is first, this is just the syntax for how you get all entities that use this system. We'll talk about entities and the simulation config later whenever we go and actually run the sim, but this is just going through that system. So whenever you want to get all the entities that have the tag for using this system, you run sc.getEntities, and then you'll get a list of all of these entities within Python. And then one of the things that you might want to do is loop through all of these entities inside of this list, and essentially do getting or setting of parameters that are on this entity. So imagine those getting and setting parameters as those parameters on an entity as sort of like information. So say you have an oxygen generator inside of there, and you want to track the amount of oxygen. The amount of oxygen would be a parameter within your system or within the entity itself. So I've written out a few notes here. So note, just look through the sc.var type for all the possible space teams types and how to get and set those parameters. Some of them use NumPy arrays for arrays, and there's a couple of syntaxing things here and there. So do look through that. And then also getting a parameter. We'll go ahead and go through the first bit of just getting a double parameter here. So here you can see in line 102, I created a variable called test double value, which is that uses the entity, and then from the entity, a member function called getParam, and then I've also told it what type of a parameter I'm getting. So here, sc.vartype.double, and I get test double. This test double variable is essentially a key inside your simulation config that you can use to grab your values out. So right now it's 0 or whatever value that we've set it to, but test double is the key that you're using.
Yeah, so basically the main idea is that everything inside a simconfig is a map. So there's a key and there's a value. The value can itself be essentially a whole simconfig. It can be what we call a param map, which is again another type of map. It's a dictionary, essentially like keys and values, right? So everything
Mhm.
is a key and a value pair.
Yep.
In this case, what you're saying is I have a key value pair where the key is test double and the value is some value of type double. And we're saying get that value using a get param function.
Okay, and then next, you can also nest these values. So inside of a JSON file, you can essentially create a nested structure. If you want to organize your parameters into sets of parameters, you can do that within a simulation config. And this is really just teaching you also how to get nested parameters here. This is a syntax for it. It's just an array of first your outside key and then the inside key, and then you'll be able to grab the value.
And you can go as deep as you want with this. You just put them all in the order that they're nested in. You put that into a list, and that's it. Don't put it into a NumPy array. It should not be a NumPy array. It should just be a list.
Correct. And then, of course, after you grab these values, you want to manipulate them. So if you're going to be creating a like an oxygen generator and you want to add oxygen or you want to take away oxygen for oxygen usage, you're going to be setting these parameters here. So really, you take the entity, which is where that parameter lives, and then you do a set param of type, whatever type that you want. In this case, is a double, and you take test double. And then in this case, what I'm doing is I'm taking my previous value within the sim and just adding 1 to it over and over and over again. And so that's really just how you can, imagine you're accruing up some sort of amount of oxygen or decreasing some amount of oxygen, just depending on the sign of that number, right?
So between the get and the set, you can do whatever math functions you want. You can have other stuff run. You can get parameters from other entities, anything you want basically between that. But the basic structure should be that you get whatever params you need, you do some kind of manipulation on them, and then you set them on either the same entity, a different entity, wherever they need to go, basically.
Correct. And of course, here is also just to teach you how to set the nested param. It uses the exact same syntax, except all you do is just take this list from your keys all the way down to whatever value you need to, and then that's just setting a parameter for adding 1. So we've added in a little bit here in line 114 to 116 just to say, okay, maybe at some point you want to exit the loop, you actually want to end the sim. So really you're going to set that exit condition to true if some condition happens, and then you'll essentially leave this up. You can do that for debugging purposes if you'd like, or if you have like a sim end event and you're saying, okay, once this happens, the simulation should end. And so you can set that flag to true, and then you'll of course break this loop and go into the leave set. Pretty straightforward.
Yep. And if that doesn't happen, if you don't put something like that in, if you basically have a while true going here, it will shut down automatically once somebody else ends the sim, whether that's you saying, okay, stop the sim, let's go back to the main menu, or if you have some other system that calls sim end,
Yep.
You don't have to shut down every system or like look out for that. It'll just do it on its own.
Correct. And then this last bit here, which is pretty useful, is if you want to have a cycle of the sim to be running at some frequency, this is the syntax in which you would do it. You would do a time non-sleep, and then what we have is a parameter on each system called loop frequency hertz. And really, you get this system's really what we call these inst params are really just parameters of just this system itself, and you get the param loop frequency, you do 1 over loop frequency, and you sleep the while loop. And that's pretty much how you would accrue for the next time step. Now I'm running at, time 2 if you're at 60 hertz second, keep on going forward and forward.
Exactly. So be careful with this though, because if you don't add this parameter of loop frequency hertz to your Python system in the simconfig, it will break. It'll say that you don't have that required parameter. So with that, let's take a look at that simconfig then.
Okay. So there it is.
It's in Sims here. So yeah, at the top you can see example Python right there, right? So the way you construct this is you'll just copy the same format that's in this example Python sim.json. You'll put whatever title you want, whatever description. That's just metadata. Doesn't affect anything. What does affect something is these systems. So if we were to collapse that, let's collapse the whole systems. You can see there are two things in here, right? There's the system manager, which has systems, which are like what we just showed. That's an example of a system. And then there are task flows. Python systems cannot go in task flows, so we'll just ignore that for the moment.
But you do need that block.
Yeah,
inside of
you
your
need that.
simulation.
You need to have that block in there. Don't delete that, but just keep it blank. Don't worry about it. The first part here is a name tag, right? Just call it something that you'll remember, make it something unique. You can't have two systems with the same name. For the source, put in where it is. This is from the packages folder down. So we see inside packages, we have template Python, right? And then inside that, we have example python.py. If it has a .py, that means it's a Python system. That's the type. If it's going to be active, if you want it to run, you say true. And then the rest is what we call inst parameters. These are just parameters that are on the system. But since a system is essentially the same type of object as an entity, you still get param from it, the exact same syntax. In here, we have that loop frequency hertz parameter, right? We set it to 60, just a regular 60 hertz update rate. And then we have two entity references in here. So the way you do an entity reference is, well, first off, you make sure you have that entity inside the symconfig, which we'll show that in a minute here. And then you say, okay, this is the key right here, right? And this is the value. The value for an entity ref is always going to be the exact same syntax. It's brackets, and then you type entity ref
Which
in
is the
this.
type
Yeah, that's the
value.
type of this. And then
You
the name
reference
of
the
your
name
entity.
of the entity.
Right? So this does not have to be the same as the key, right? But this right here does have to be the same as the name of your entity. So let's
scroll down to the entity.
let's collapse a couple of these other systems so they don't get in the way. And then let's check out what we got here. So we'll skip past the sim entity. We'll go over that in a future video. And let's go to one of these entities like the spectator.
Let's go down to entity one
Right.
and show him.
Yeah,
show
the spectator is just your camera in the sim, but entity one, that's the one we were referencing, right? So it has a name, entity one, and you can copy all of the syntax exactly for whatever system you're writing. And then it has example Python, which is the name of our system right there. That's part of its systems. It has these other two, which we'll go through later. And it has some required parameters like dynamics, graphics, that kind of thing. And then over here, we notice test double. That's the exact same name that we had back up here, right? So here it is appearing inside the symconfig. And if it's a double, you don't have to do anything special. You just type in the number. You don't have to do any brackets or any type definition. It's just that, okay? If you want to have a nested param, it's curly braces and then put your other params. If you want to have a double nested one, it's curly braces, then the name of the other one, more curly braces, and then whatever params you have, right? It just scales like that all the way down.
Yep. And those two parameters, the test nest and test double, is from, inside the example Python.
Yep.
Those are the same values.
And a couple other notes here, right? If you want a vector, like say for a location, it's a three-dimensional vector. That's called double v3. And you just identify that that's the type, and then you put in the three values that contain it. Whoops. And then say if you have a rotation, we represent that with quaternions. That's a 4 vector. That's just double v4. And then you put in the 4 values. We have a convention of scalar last for quaternions. And everything else, self-explanatory, velocity, acceleration, these are all the same kind of 3 vectors here. Yep. And then for real quick, just to go through the dynamics category here, if you have an inertia and a mass for your entity, whatever it might be, put those in here. If you have any forces and torques that are going to be on them, just put in these force and torque parameters and then set those at runtime as needed. Impulses can also be added at runtime, which will be a later video. And then importantly up here, this right here is rebase center. Set that to be whatever you want to be the center of your sim. Generate collider, don't worry about it. And then propagation type is basically how deep do you want to go into interpolating between time steps for it. So in this case, since we're doing some dynamics on it eventually, we're going to put compute acceleration. So it's going to figure out the acceleration that it's experiencing and then use that to get a smoother kind of interpolation between frames.
For the purpose of this example simulation, no, we won't be propagating anything. So we're not going to be using these parameters, but those would be what you want to use to set up dynamics later on with what we have inside of a rigid body propagator system.
Yep. So anyway, let's actually run this thing now. So we're going to go to let's go to here, and we're going to go to where it says spacecraft. This is our top level directory again. We're going to go into spacecraft, and it says spacecraft.exe. That is the space team's executable. So let's double click that to run. And we're going to log in. And then if we go to sim, we see we already have it pulled up here, but let's say we didn't have that. So how do we find it? Well, you just search. We know it's called Python, so search for Python and look at that. There's our example Python sim.json. So we'll just enable ray tracing because we can. And let's enter the sim. So what you see in here is, you see there was here's my first on-screen message / alert. And then here's an on-screen log message. So you see both those printed right there. And then what we see in here is we have, I believe this is entity 1, I think. This entity 2. One of those is entity 1, one's entity 2. Basically.
I believe that one was entity 2.
Yeah. So it's just 2 rocks representing our entities. For the moment, they're not doing anything. You can see they're just kind of sitting there. That's because we haven't told them to do anything. We're just setting some pretty much invisible params on them that test double. It's not really doing anything in sim. So the next video, we'll go through how to actually do something.